Okay, so we're going to do lesson 2.4, and I'm going to divide this into two parts, so this will be part 1. And so let's get started. Factor and solve polynomial equation. This section is, the problems aren't terribly difficult, but they do involve a bit of work, and so this assignment probably overall will take about 2 hours. So we'll do part 1 today and get going as much as we can on the assignment, and we'll also do part of the study guide, and let's take a look at that. So those of you taking Cornell notes, you can write down the objective and the essential question. So what we want to do is we want students to be able to factor completely polynomials, and we also want to be able to solve these equations. What happens in business lots of times is we might have a polynomial like this, and we might graph that polynomial, something like this maybe, and these regions that are trapped by the x-axis, like from here to here, these regions are often important regions. Like in business, for example, this might represent the profit of something. Okay, so that would be this region right in here. So there's other applications as well, of course, in physical sciences as well, where we might have to know certain things. In any event, these points here along the x-axis, they're called zeros, or sometimes they're called the x-intercepts or roots or things like that. And when we factor a polynomial, this often allows us to find these boundary points. So that's kind of why we want to do this, but in many ways it's annoying, and also in many ways we'll be reviewing the factoring that you learned in chapter 1. So let's get started on it. Yeah, get the right thing here. So we're going to start out by talking about factoring completely. And basically that means that all the factors are prime factors. So you might remember when we had prime numbers, like 7 is a prime number. Why? Well, because there's two integers that factor, two integer factors only, like 1 times 7. However, 10, of course, is not prime because you could write it as like 2 times 5. And besides 1 times 10. Okay, so there's multiple factors of 10. Well, the same is true when we're factoring. If you have this idea, or if you have a factor and you're factoring along, and you have some factors here, and you have like 2x minus 10. Well, it turns out then that this factor is not a prime factor. What we mean is that we could still write this as like 2 times x minus 5. You see? So that's what's sort of meant by factoring completely. If you have a factor among your factors that can be factored further, then you're expected to do so. And so this example above, hopefully you understand what I did there. Let me redo it here in slow motion, kind of show you that step. So the first thing we'd do is we'd say, okay, that's 2 times x. This is 2 times 5. So the common factor is 2. So we'd factor out a 2. And what's left goes on the inside of the parentheses. So x goes here. And then, of course, this sign's negative, so we'd have x minus 5. And so that's how we do that. Okay, but there's another way we have to factor completely. Like, for example, let's say we're factoring along and we have, let's just say 9x squared minus 16. Well, you learned way back in chapter 1 that the difference of two squares looks like this, a squared minus b squared. This factors to like a plus b and a minus b. So that's a special factoring that you should remember. And so this factor is not complete yet. What we need to do is factor this, and so what we'd have in this case, we'd have 3x minus 4 and 3x plus 4. And so I'm not going to reteach all that stuff on how to factor this, but again, that's something we learned in chapter 1. And factor completely means that every single one of these factors will be basically what we call prime. There's nothing left that we can factor. Unlike this one, we could factor a 2 out. So that's what's meant by factoring completely, and it's automatically assumed that when we're factoring that we're supposed to factor completely. So anytime we have a test or homework, you're expected to do this, and we're going to see lots of problems. So let's just look at some examples now. Okay, so one of the first strategies we want to do is look for common factors among all the monomials. And I notice that there's an x in each one of these. Okay, so let me show you a couple methods on how to factor this. To be quite honest, I usually do it this way. I look for the common factor and I say, okay, x is my common factor. There's an x here, here, and here. Okay, then honestly what I do now to figure out what goes on the inside, I just look up here and I say, what do I multiply by to get x cubed? And hopefully you say, oh, x squared. Okay, and then I say, what do I multiply this one by to get 2x squared? I say, okay, I have x. What do I need? It looks like I need a 2x. Okay. Oh, whoops. Let me back that up. I need a 2x. And then I look up here and I say, what do I need to multiply to get this one down here? I have an x. It looks like I just need a negative 15. Okay. And that's kind of how I do factoring. But, you know, if you need to, I could show you another way to do it. What you could do is rewrite this as like x times x squared. That of course equals x cubed. And then you can write this one as like x times 2x. And this one you can write as x times negative 15. And now once again, the common factor comes out in front of the parentheses. So the common factor is this x sitting right here. This x right here. Okay, and there's a common factor here and a common factor here. So the common factor comes out front, and then what's left comes on the inside. So you have x squared plus 2x and then minus 15. So there's our first problem. Okay, now we're not exactly done yet though, because the factor that remains in here is not prime yet. We can write this in factored form now. And you might remember again from chapter 1 where we look at two factors here that give us the middle term. And we know two factors here are going to be x times x, right? And two factors here that would give us the middle term are probably, well, 5 and negative 3. So it turns out that this trinomial factors to x plus 5 and then x minus 3. So now that's what's meant by factoring completely. Every one of the factors is like a prime factor. Okay, so now let's try B. Well, on this one we need to factor what? We can take out a cube, right? There's a y cube. Oh, and there's also a 2 that we could take out. And usually when you're factoring, you factor out what's called the greatest common factor. So you want to take out as much as possible. So for this one, we're going to take out a 2y cubed. And again, you can just kind of look up here and say, well, what do I need to multiply by to get 2y to the 5th power? Well, there's 2y to the cube power, or to the 3 power. So what's missing is a y squared. And then you look at this one and you say, okay, well, there's missing a 9, it looks like. Well, so it looks like we're almost done factoring, but here when you examine this factor, this one can be factored further. So that's a difference of two squares. We've gone into that before, so we want to factor this one more time, or continue along, and we get y minus 3 and y plus 3. And now we've factored this completely. So be careful, make sure you're looking at all the factors and continuing factoring if you can. Okay, just remember, had this been y squared plus 9, this one that we would say is prime. It does not factor. So again, those are some ideas we had in chapter 1. Hopefully this is all a review. Okay, well, let's look at a third one here. Looking among these three terms, I've noticed that there is a common factor of a 4 and a z squared. And so, by the way, I'm going to write this up here because some people can't see it on my whiteboard. So this is 4z to the 4th power minus 16z cubed plus 16z squared. So it looks like to me there's a common factor of, say, 4z squared, right? There's a z squared here, a z squared in all these, and then there's a 4, right? Well, once again, if you just look up here and say, what do I need to multiply to get 4z to the 4th power? I have the 4, I have a z squared. It looks like all I need is a z squared here. And then if I look here, it looks like I need what? A 4 and a z. And looking over here, it looks like I need a 4. So I get plus 4. Now, every time you're factoring, you should look at all the factors separately and see if the factors can factor further. Well, it looks like this could factor still, because there's two factors here. If I use negative 2 times negative 2, that would allow me to get the middle term here by adding. If I add those two, I get negative 4. So it turns out this factors one more time. And I get z minus 2 and z minus 2. Oh, by the way, since these factors are the same, we probably would go one more step and write this as z minus 2 squared. Phew. Okay, so as you can see, these problems are fun. Yeah, right. Okay, so anyhow, that means that's the idea behind factor completely. There's several problems on the study guide and several problems on the homework assignment that you can do now. So I'd take a few minutes to maybe do a few. Let's continue though. There's one more idea I want to cover, and that's the sum and difference of two cubes. Now, you'll notice there's a special pattern here. And patterns aren't new. You've actually seen patterns before. Like, for example, when we did the difference of two squares, we saw that that's a special pattern. That's going to give me a minus b and a plus b. But you've also seen this one, a squared plus like 2ab plus b squared. This is another one of those special patterns. This one always factored to a plus b squared. And this one, a squared minus 2ab. This is another one we've seen. This one factors to a minus b quantity squared. So those are some special patterns from chapter 1. And by the way, we have another one here. A squared plus b squared is prime. Can't factor it any further. So that again is a little review of chapter 1 and some of the special patterns that we've had already. Now, this looks complicated, but I'm going to share with you a couple ideas here that hopefully will make this easier for you. First of all, the first factor that's sitting here, it's exactly what we have here without the cubes. You know, so That's going to be tricky though. And what comes here now, it's very similar no matter which case you have here. Notice the a squared is the same, the b squared is the same, the ab is the same. In fact, everything looks very similar. Another similarity is that this sign is always positive, and this sign here is always opposite of whatever you started with here. It's always opposite, okay? And again, notice here, this sign here is always opposite. Okay, so now what I'd like to do is just do a few problems and show you how to set this up. I think after you see this 2 or 3 times, you'll say, oh, it's pretty easy. So let's look at a sample problem. Okay, now to be able to factor this, and notice we have the sum of 2 cubes. In order to factor this, we're going to need to know what a and b are. Now, before we go much further, I want to review with you the cubed numbers, because part of these problems is just recognition. So let's just review the cubed numbers. Like 1 cubed. That, of course, is equal to 1 times 1 times 1, which is equal to 1. And then we have 2 cubed, okay? Well, that's equal to 2 times 2 times 2, which, of course, is equal to 8. And I'm not going to continue to expand these, but you should know all these cubed numbers. Like 3 cubed is equal to 27. 4 cubed is equal to 64. 5 cubed is equal to 125. 6 cubed equals, let's see, this one, I think it's 216. Okay, and then 7 cubed is 343. 8 cubed, I believe, is 512. 9 cubed is equal to 729. And 10 cubed is the easy one. It's 1,000. So these first 10 you should probably know, because they come up all the time in these factoring problems. Okay, so that being said, you should also do the cube root. So let's take a look here. In order to do this factoring here, again, you need to know what a and b are. So what I do is a little preparatory step here. If this is a cubed, what's a then? Okay. Well, remember, the idea between here is what number is multiplied by itself 3 times. So a needs to be some number that's multiplied 3 times to give you the original number that we started with. So it's a number times a number times a number, and it equals 8x cubed. Well, hopefully you're not thinking too hard about this. Hopefully you recognize what a is. A would be equal to 2x. And if this is b cubed, then what's b? B would be equal to, of course, 3. And that's because 3 times 3 times 3 is equal to 27. So hopefully you get the idea. So this is our preparatory work, and then all we do is substitute all the a's and b's in here. And here, you know, so that you just have to substitute that all in there. Now it's not as bad as it looks. Okay, so let me just show you. This first factor is these two numbers. And so if you have a plus here, this is going to be plus. You see there? So you're going to end up with 2x plus 3. Now, what I do is, I'll just show you what I do. Is my way of doing it. I square this one. By square, I mean 2x times 2x. And I do that step in my head. So I write that as 4x squared. And then I square this one and put it over here. Put 9. And then I multiply the two together and get 6x. Now this sign here is always positive, and this sign is always opposite of whatever you started with. So that means it's negative. And so there we have it. We're done. I know I kind of did that fast. So let's do another one, and I'll repeat the steps. And hopefully you'll start to realize, hey, this pattern's not that hard to remember after all. It's pretty easy, actually. Like I said, after you do 3 or 4 of these, hopefully you'll have the pattern memorized. So let's look at a second one. So the first step is to recognize that this is a cubed number. 4 cubed, for example, is equal to 4 times 4, which is 16, times 4 again equals 64. And so if this is my a cubed, then what's a? Okay, well, if that's a cubed, then a has to be 4x. Don't forget the x. Okay, and if this is b cubed, well, hopefully you recognize, well, then b has to be 1, because 1 cubed is equal to 1 times 1 times 1. And so the first factor, in this case, oh, by the way, we do have a difference this time. So the first factor you're going to subtract. So we're going to have 4x minus 1. And now let's see what comes up next. Square this one. Well, if you square this one, you get 16x squared. Then what I do is I square this one. You get 1. And I multiply the two together. You get 4x. This sign is always positive. And this sign over here is always opposite of what we started with. So if we had a negative here, it's going to be positive here. You see, so it's not that bad to memorize this pattern. Like I said, after a while, after you do it 2 or 3 times, you'll have it kind of memorized. Notice also I have it written on the board. I will have it written on the board on the day of the test as well, so those of you who can't remember it, it's fine, it'll be there. Anyhow, what I'd like you to do now, this is where I want to stop basically for my my lesson. I'll do part 2 tomorrow. And what I'd like you to do now is work on your study guide a little bit. And let's look at a couple here. Make sure you can do your study guide. 2.4. Okay, so you should be able to do the 3 vocabulary words here. And you should be able to do some of these study guide problems now. Let's look at number 2 though. I'll help you get started here. We have 128 y to the 6th power plus 2. Why don't we just do this one together real quick? Okay, the first thing I notice is that there is a common factor between the two of these. So I'm going to start out by taking out the common factor. We'll call this factoring out of 2. And again, what do I have to multiply by? Let's see. 2 times 64 will give me 128. So I have y to the 6th power. And then looking over here, it looks like I need a 1. Okay, so when we're factoring, we're going to need to factor completely. So we need to examine, is this factored completely? Well, I notice this number here is a cubed number. In fact, that's 4 cubed, right? That's equal to 4 times 4 times 4. Now check this out. This is also a cubed number. So the way we've been doing this, we start out by saying, okay, if this here is my a cubed, then what's a going to be? Now this is a little tricky the first time you do it, but a is going to be 4y squared. Now think about this. I'll do it over here on the side. If you were to cube this, you'd have 4y squared times 4y squared times 4y squared. So 4 times 4 times 4 is the 64. And then y squared times y squared times y squared is y to the 6th power. So indeed, that would be your a. Now this one, if this is your b cubed, then what's b? Well, b would be equal to 1. Okay, so what we need to do then is factor this, because this is a sum of 2 cubes. And so we have the 2 sitting here, And then what? Then we have this factor that's always going to be in front, and so you're going to have a 4y squared plus 1. And then how do you get these here? Well, to get the first one, you square this one. Now think about this for a second. Be careful here. When you square this one, when you square this, if you were to square that, you'd have 4y squared times 4y squared. So you're going to end up with 16y to the 4th power. And then I square this one, and you get 1, and then multiply the two together, and that goes in the middle. So you end up with 4y squared. This sign's always positive, and this sign's always opposite what you started off with. So let's see, we had a plus. That means this one's going to be a minus. Okay, so now we're done factoring. Now I just want to give you a one word of caution. Sometimes you have to check these factors carefully. This factor here, it actually would have factored if that were a negative. You see, if that were a negative, then this would have factored further. Okay? In fact, that would have been a difference of 2 squared, so we would end up with 2y plus 1. And we would have had 2y minus 1 for that part, and a 2 here. And then we would have had 16y to the 4th minus 4y squared plus 1. Now, you also have to sometimes check this factor. Turns out this time it does not factor, but in a few rare cases, this might factor. So be careful. Be checking each factor always. Like I said, in this case, this was actually a plus. So the sum of 2 squares doesn't factor. And so we had it correct the way we had it originally. So in any event, be careful. Be constantly looking at each of your factors to see if they factor. Okay, well that's the end of part 1. You can do several problems on the study guide now, and some of these problems you're going to have to wait until tomorrow to do when I do part 2. Okay.